I am Jason Stangroome, for those of you who don't know me. I work for Section.io. Several years ago, Section.io was established to provide a fully managed service to people that were running websites that had performance issues that were impacting their revenue. We would ask the site owners to point their DNS records at our system, and we would take care of the rest. You could distill our toolset as essentially just the web browser dev tools and so a series of content rewriting HTTP proxies, and that was how we would fix all the various issues. As we would not get access to the source code of their app, we would not get access to make changes on their web servers. If we were lucky, they might have something like New Relic with agents installed and would be given access to the portal. We've learned a lot over the last few years providing this service, and we've used that to take our fully managed service and now offer a self-service CDN as well. But today I want to share some of the experiences that we've had, some of the issues we've encountered, why they happen, and how to work around them. So, to give you some context, the kinds of sites that we're working with are typically e-commerce, news and forums, brochureware. They come from a bunch of different platforms. Some of them are out-of-the-box CMSs, like Magento running on PHP with some custom plugins, to completely bespoke ASP.NET applications, and pretty much everything in between. Now, one thing that's common about all these sites is that they're predominantly back-end rendered content. We're not talking about single-page applications. We're not talking about client-side view engines. They have mostly content that doesn't require user authentication. They have traffic that's really spiky. They'll participate in marketing events like Click Frenzy, or they'll have regular EDMs that they send out. And often the site owner doesn't have the skills or resources to improve the performance of their site through changing their site code, or at least not as efficiently as we can do it for them. So probably what's also important here is not just the kinds of sites that we typically work with, but what it means for us for a site to be fast. There's one aspect, aside from the first three, that are hopefully fairly clear. One aspect that we think is really important is availability. And that's because a page that doesn't load is essentially the ultimate slow page. And you might be able to serve a 503 service unavailable within milliseconds, but that doesn't help anybody. So I mentioned earlier spiky traffic. And to take one example, who's familiar with the Shark Tank TV series where cool entrepreneurs pitch their business ideas? We had, I think it was 2-3 weeks ago, the premiere episode of season 2. And one of the sites on there, they came to us and said, look, we know we're going to be on the TV. Can you set up our site so it's going to cope with the traffic? Sure, we'll help them out. Prior to the episode going to air, we would see typically 5,000 requests in an hour going to their site. In the 1 hour that their episode broadcast across the Australian East Coast, they did 750,000 requests. And that's not something that you're typically going to be building for when you're building a site. And you don't necessarily want to have the capacity to deal with that all the time, but there are times when you need to do that. And not only were we able to cope with that traffic for them, but we kept their median page load time stable during that period as well. Can't always be said the same for a lot of the other customers, or a lot of the other sites for businesses on that show. Now, For those of you who share my passion for security, you may have heard of WebGoat, which is the OWASP demo site, which is built intentionally insecure for demonstrating problems. I don't have a WebGoat for slow performance. Most of our customers, we've fixed their issues, and other sites out there, it's probably a bit unkind to be pointing out as a negative example. So I'm going to do my best to walk you through a lot of the scenarios, and if there's any questions afterwards, I'll try and clear them up for you. So I want to start with caching in the browser. Basically, every request that you can avoid making out of the browser is going to be a big win. It's a win because that's a DNS resolution you don't have to do. It's a TCP handshake and the 2 to 4 round trips that don't have to happen. You're not waiting for the server to render the content. And even more importantly, you're not having that load impact on the server. So the server is then free to handle responses that are going to be more important for the service that your site ultimately provides. And so the first thing we pretty much find ourselves doing on every site is dealing with cache control headers and expires headers. There's things like cache control no cache, no store, max age 0, or expires headers where the timestamp is in the past or the ridiculously near future. And these are on resources that are essentially, should be cacheable. They're static resources, they're logos, they're style sheets. There's no need for them to be that way. So we often find that's the very first thing we have to fix. And it's also important to do it in a way that you're not still having your browser go off and do the if not modified request with an E tag, which then has to wait for the server to come back with a 304 not modified, because you're still paying that connection and round trip cost. Query strings are another good one. When you get to the application code, most programming frameworks are presenting your query string keys and values in a way that's kind of irrelevant as to how they appeared on the query string, on the URL. But from a cache perspective, especially in the browser, there is an importance to that order. If they're out of a different order, that's a different URL. That corresponds to a different cached object. And so you want to be really mindful that you're always generating URLs where the keys are in the same order so that they can align up. And sometimes you want to look at options where you can do sorting on them. Another common use of query strings, but it's not limited to query strings, is cache busting. You've probably seen the model where whenever you deploy a new version of your site or a new batch of content, you want to update the query strings to force any long period caches to refresh immediately and bring all that new content down. And a common pattern, and a good pattern, is where the query string gets injected with a timestamp, which correlates to the time of the deployment, or maybe the time those files are modified. However, we had one particular example where they'd obviously seen this idea and thought, I can do that. But their implementation was such that they had a bit of script in the page that would find all the image elements on the page and change their URL so that the query string was the current system timestamp. Yeah, don't do that one. In this case, being a proxy in the middle, we're able to rewrite the script on the way through and replace that with a much more suitable timestamp. Yeah. Protocol relative URLs. Who thinks these are cool? Is that because it's a trick question? I used to think they were cool, especially when you compare them to the alternative model where usually with some server-side code or some JavaScript, you're detecting whether the page was accessed on HTTP or HTTPS and then updating all of your URLs so that they have the right prefix and you don't end up with the annoying mixed mode warnings and the broken padlock and all that kind of stuff. A while ago, protocol relative URLs got some good publicity. They've been in the spec since basically day one, where you can just chop everything up to and including that first colon off of the URL, and it just goes, oh yeah, whatever the page is using. But here's the problem. User is browsing around your site on HTTP, and they're caching your logo, your main style sheets, your scripts, lots of other assets that appear on a lot of pages. And they're all using HTTP URLs. And then they hit the first page on your site that requires HTTPS. Maybe it's login, maybe it's checkout, who knows. Everything on that page is now referring to HTTPS URLs. And it doesn't have those in the cache. And so now it has to go off to the server to get all of those resources again. And 99% of the time, the responses it gets back from the server are identical to the responses it already had in its cache, because those statics aren't actually different. They just needed to be served on HTTPS to avoid the mixed mode problems. And so the moral of this is, if a resource is available on HTTPS, always use the full HTTPS URL. It doesn't matter if you're on a HTTP page or not, it'll just work on a HTTP page, and on HTTPS then you avoid all the mixed mode, and you get to reuse the cache, and all those pages are going to be great. And prefer get over post. The HTTP spec basically says that a cached response cannot be used to fulfill a post request. And so as soon as you start using post, there's no caching. And often that's very appropriate. But there's another scenario where post often gets used. And that's when the amount of data that you're sending feels like it's too much to put in the query string. And so you want to use the fact that the post has the request body, you can ship that payload. And this used to be a bigger deal with older browsers having quite tight restrictions on what the URL length was. But today it's not such an issue. And we found a particular customer who their search page, because it had various facets and filtering and sorting, would just bring up a basic sort of shell of a page and then do an AJAX post to actually fill it in with all the content. And then furthermore, all their various category landing pages around the site were just sort of a friendly wrapper over that. And so they would load this placeholder page and then do an AJAX post. And on the server side, doing search queries, pulling through all the data for all the products that come up in the query, they tend to be expensive operations. And none of this was cacheable. In this case, we found that we couldn't just change it to a get. If we hit the origin with a get, the origin was going, nah, not cool. But we were able to, as the HTML and scripts are being rendered to the browser, rewrite the scripts with a little bit of jQuery that's doing a post, now does a get and puts the data in the query string instead. And then when it came into our layer, we were able to see if we had it in our cache and serve it, and if not, write it back to a post and send it on to the origin. And that gave them a huge boost, not just in terms of page load times for what was essentially a significant part of the site, but also really dropped off the resource usage on their origin. I don't want to spend too much on this slide. This slide is hopefully what I could call the boring stuff. It's what every performance web talk ever covers. The problem is that, again, we still find ourselves having to do it on every site. Because, yeah, scripts and style sheets are all, just lots of them, not compressed, not minified. Images are ridiculous resolutions for the size that they're showed on the page. And a lot of it actually comes down to CMS systems. They've put the onus of needing to understand what is an appropriate image format, what is an appropriate resolution, how to strip out the Adobe Photoshop metadata and color profiles. They've put all this onto the people who are responsible for uploading the content. And these people aren't typically hired for that skill set. And what you really want is a CMS system that is going to take a lot of that and go, I know how this is going to ultimately be rendered on the page. I should be doing the transform now and persisting them in the right formats ready for the site. We happen to do all the rewrites on the wire and then store it all in a cache. And that works good for a CMS system, but otherwise, for all your statics, get it as part of your build solution. And the only one I'm going to call out here is HTML. get your image dimensions into your HTML, because it's going to help with the page render times as well, when it can already know where everything's going to fit in before it gets the image down. Okay, so scripts, right? So many sites. If you have your marketing team have any say in what your website does, you probably have 10 to 30 third-party scripts all being injected into your page to track all kinds of things about the user. And they're all being loaded synchronously, and they're all being told by the people that provide the third-party script, you should insert this snippet in your head of your page. And you get this lovely load bar down the bottom where it's like, yes, we're passing some HTML, and then we stop while we go and download the script from another domain, and then we run the script, and then, okay, now we can continue. And meanwhile, your page is just sitting there waiting, showing the user nothing. So we solve this a lot of the time, essentially by deferring the scripts. We go and hunt down whether those third parties actually offer a deferred script option. And if they don't, we rewrite it where possible to be a deferred script. And then we just rewrite that in the page on the way through. And we can do this because of a few things. One, that most of these things don't have a visual component on the page. They're more about gathering data and sending that off. When they do have a visual component on the page, it's usually not critical path. It's like, a little pop-up overlay in the corner. It's like, hey, can we talk to you, or something like that. And our customers have come to us for performance. And so they're happy to say, I would much rather have a faster page than have that stuff load immediately. Because there is a cost. Is when you defer all that stuff, you do create a situation where some customers will occasionally find what they want on the page because it's rendered quickly and they know what they're looking for, and click through and navigate off to the next place. And this will happen before those deferred scripts have finished downloading, have finished running, and had a chance to send off their data. And so you are trading off page load performance and a better user experience for potentially a lower quality or a lower sort of feedback rate on your marketing data. There is a web API improvement coming through called Send Beacon, which we'll start to see implemented in the browser soon, which basically means that a page can say, hey, here's a bit of data that I want sent. Do it in your own time. When the browser's idle, even when the user has navigated away, it can finally go, hey, I'm going to send that off. And that'll help give you the combination of deferring a lot of this stuff while also being able to get that data. It's also interesting to think about where those scripts are coming from, because that's often why they're slow. Sure, you might have a lot of scripts coming in, but it's the fact that they're not coming from your domain. They're coming from another domain, which means another DNS resolve, another connection handshake, another request to pull that back. And they're not always the fastest. The good ones are. They're on a great CDN of their own, but it's still another request going on elsewhere. And there's a big trade-off here as well. If you're using a script that is used by lots of other sites, and they're all using the same URL as you, then there's a really good chance that when someone comes to your site and they've been to one of these other similar sites, then that stuff is already cached in their browser and you're not going to cop that hit. But at the same time, you want those URLs to be things that they're versioned specifically, because we've had stuff where marketing scripts, third-party scripts have been pushed to their CDN endpoint and they've broken. And you just see all the sites depending on them simply stop tracking data, or worst case, if they've coupled to them in their logic, they start to have JavaScript errors on the page, which means other parts of the page start to fail and the site becomes unusable. It's also important to think about availability. While a lot of these other third-party endpoints are built to be highly available, there's always this possibility, and we see it often enough, where a particular ISP's network routing to certain segments of the internet just means they might be able to access your site, but they can't access some other domain, which is where this stuff is hosted. And it becomes a way to think, maybe I should bring this onto my domain. And wherever that's possible. It isn't always. It's certainly something to be aware of and look into and understand the impacts of that. Everything I've covered so far is pretty much client-side. But there's also a lot of stuff that goes on the back end, on the web server. In fact, there's so much that goes on the back end that we could probably be here and do a week-long course on different performance issues there. But there's a few that I've just found to be particularly interesting or perhaps non-intuitive that I thought I would mention today. So, how much does it cost you to render a 404 page? Right? We think about all these sites that have dynamic URL, human-friendly URLs and stuff like that. Request comes in, it hits your application server, it then goes off to the database to see if there's a product or a category or a content article that matches that, realizes that it doesn't, so it now goes and renders a 404 page, which is a nice custom page, which shows popular links that other people like to visit and products and stuff like that. So it has to go off and make other database calls. And eventually you return this 404. And that might be fine to do for the occasional hit. But the web has bots. There's the bots that you love, like the Google crawler bot that gets you indexed and how people find you. There's more niche search engines, which can also be useful. But then you also get, scraping bots that are just harvesting your data to show elsewhere, and suspicious vulnerability scanning bots. And when these things get going, you can end up with thousands of requests, each requesting a different URL, and all of them 404ing because it's just trying a dictionary scan or something it's seen on another site. And when that starts to build up, it gets really interesting, the patterns that happen. So in one particular case, the effort to do the 404 and look up all that data was having a big impact on the system, but the origin was doing its own caching. As a CDN, we can't do much to cache 404s for all these variety of different URLs. We can cache them, but then they don't get asked for again, so we're not going to serve it. And then a different one gets asked for, it goes to the origin. The origin was trying to do its own caching. And what it was slowly doing was pushing all these cached 404 responses into its local cache and filling it, and then getting to a point where there was enough cache pressure that it had to evict all the other pages out of the cache. And these were the pages that corresponded to legitimate user requests of trying to use the site properly. And the whole thing just ground to a halt. Server-side state is another great one. Lots of servers love to give you a session cookie as soon as you rock up. You turn up on the page, your first request, you don't have a cookie, bam, here's a session cookie, and I'm going to go and store some server-side state about that. Maybe, what your user agent is, what URL you asked for, when you last came here. And again, a lot of bots are dumb. They're not running full web browsers. They're not running Phantom.js. There's a few, but most of them aren't. They're using curl, they're using your web framework, and they don't come with cookies. And when they get given a cookie, they typically drop it on the floor. And so we saw another site where this bot would just come along and it would give it a new cookie and it would go and store some session state for it every time. The last URL it went to, what timestamp it was. And it got to the point where it was filling their session storage such that they couldn't update it without these massive contention. And so they're just killing themselves with this. And it doesn't have to be bots. We had another great customer. They have a particular pattern. They like to, pretty much every week or two, on the same day of the week, at the same time, relaunch some new products. And it'll be, bang on this time. The customers know it. They all want to buy this product. There's limited stock. And they would do easily, within half an hour of this sale launching, sell out all their stock and 50,000 plus revenue in this spot. But they had a really hard time getting to that because the act of going through the checkout, which again, as a caching CDN, Checkout is a personalized experience for each user. We can't handle that. That has to go through to Origin. The contention on taking all the rows in the cart table and moving them into the order complete table and then updating the inventory levels for each product was having such a massive impact on the database that they just couldn't process the checkouts. We had offloaded all other traffic of the site, all the images, all the product pages, all the homepage category, everything. The only traffic hitting their site was checkout. And these were legitimate users trying to give them money. They ended up having to switch to a model where basically a different data store with different consistency models that were more appropriate for that situation. And it sort of touches on the idea of what is it about your site that you really need to provide to generate revenue or to fulfill what it is your customers come to get. There's lots of all these extra fancy features that you can offer, but when the time comes, when you're under a lot of traffic, can you give your operations people the ability to say, you know what, we don't need that feature. We don't need to tell people about other products you might like right now because that's costing too much server resource for us to just sell them what they've come for, and be able to turn that off. Another example might be YouTube choosing to turn off commenting so they can continue to stream video. So I mentioned earlier that you shouldn't look at protocol relative URLs. You should just put everything on HTTPS. And historically, the reaction to that is, but HTTPS is slow. But that argument is exactly that, historic. TLS is fast now. We've had massive improvements in computation capability, and that means that the protocols as well have been optimized so that, you know, with dynamic record sizing and session tickets, this stuff is all really fast. And once you're on HTTPS, you then open up the capability to do HTTP2. So the HTTP2 spec, while it allows, just like HTTP 1.1, to use this new protocol over insecure clear text protocols, none of the modern browsers support it. All the ones that do support HTTP2, and we're talking Chrome, Edge, Safari, Firefox, they all insist that HTTP2 must first be over HTTPS. And then once you're on this, you get a lot of wins. Firstly, multiplexing. So in HTTP 1.1, you can send one request down the pipe and wait for a response before you can send the next one. And your browser will typically open a whole bunch of connections to your host, so it can do more in parallel. HTTP 2 doesn't need it. You do the connection handshake once, the TLS handshake on that connection once, and then everything just gets multiplexed down there. Beyond that, it gets even better with server push. If you imagine a really basic site, you have a page. On that page, you have your style sheet and your script. Right? Keep it simple. The browser requests the page. Server provides it. Browser starts to pass the markup, gets to the point where it realizes that there's a style sheet and script reference in there, checks its local cache, doesn't have it, starts to send a request off to the server to say, hey, I need these things too. Difference is, the server knew all along that you're about to ask for these things. It sent you the page with those references in it. HTTP2 lets the server realize that you've just asked for this page, and I know that there are other resources in there. So I can start pushing those responses down the multiplexed pipe at the same time. And so now when the browser gets enough of the markup that it starts processing it, and then gets to the point where it finds those references, it then looks over at the HTTP2 part of the conversation and goes, I've already got those. I can now continue the rendering process immediately. And server push is available in all the same browsers that support HTTP2, with the exception of Safari for the time being. There's a lot going on in HTTP2. I don't want to try and cover all of it today, but I want to call out one, which is really important as you transition from a user base which is going to be predominantly HTTP 1.1 and slowly gaining momentum in being a HTTP 2 capable browser base. And that's to do with domain sharding. So if you're not familiar with it, domain sharding is basically where HTTP 1.1 was giving you too many limitations on the number of concurrent connections. So you could download as many resources as possible in parallel. So you start doing images.mydomain, or assets1 and assets2 and assets3.mydomain. And so the browser thinks they're different servers and starts to open up even more connections and start pulling stuff down. In HTTP 2, that doesn't benefit you because it's all optimized for that single connection, that single handshake, and then multiplexing everything down the same pipe. If you give it this need to connect to other domains, you're just creating more handshakes and more latency. Luckily, they've thought about this, and there's a special configuration you can use with HTTP 2 that is going to let you transition better. And it's basically these two criteria. One, all your sharded domain names, make sure they all resolve to the same set of IP addresses as your primary domain. Step 2, the certificate that you use in the TLS handshake on the primary domain needs to include those other domains in the certificate, either through using a wildcard certificate or through using subject alternative names. Then what HTTP 2 does is it realizes, that's just the same thing. I'm going to use my existing multiplexed connection, and I'm just going to ask for those resources along that. Now, hopefully it's obvious. I work for a CDN company. This slide was inevitable. When it comes to building a site that's going to scale and be fast, inevitably you're going to look at a CDN. There's some things that you just can't do at the origin. And one of the main ones is obviously improved network latency. And from an efficiency perspective, it's just a lot more affordable and economical to cache with a CDN technology rather than trying to deal with that with origin level caches. And a lot of the optimizations you need to think about are exactly the same ones as caching in the browser. So all that stuff from that much earlier slide about cache control headers and all that sort of stuff all applies. But there's a few extra ones. Namely, cookies. Cookies are death to a CDN. And it's why you quite often see CDNs only used on a static subdomain that's only responsible for all your images and style sheets. Stuff that doesn't have any user context. And being on a different subdomain means it doesn't carry the cookies with it, typically. The reason is that from a HTTP perspective, a cookie indicates something special about a user. And when you look at all the different web server products and web programming frameworks around the world, there's typically only one cookie that's important for that, and that's the user's session cookie. But every single one of them calls it a different name, and it has different values. And there's no reliable way as a caching proxy in the middle to identify that safely and separate between what needs to be user-specific and what doesn't. A great example was Steam in December, and Menulog just 2 weeks ago. They got this wrong and basically ended up caching one particular user's personal data and then serving that to other users. Not cool. And so what you really need in a good CDN is to be able to tailor it to your site so that you can tell it which cookie is important, which cookie identifies a user, and when a user has that cookie, which pages that applies to. Because another big problem on that is the aforementioned third-party scripts. So many of these are using cookies to track the data for their marketing system. And while cookies have an attribute, the HTTP attribute, that lets the server say, hey, this is just for communication between the server and the browser, don't give it to JavaScript. There's no inverse. There's no identifier that says, hey, a cookie is just for the browser, don't send it to the server. There is web storage APIs, but for various reasons, the uptake on that for that model just isn't there yet. The other one that's interesting is the vary header. So there's a whole different bunch of ways you can do sites that work for both desktop and mobile and maybe tablets in between. You might decide to have a separate m.dot domain site that you redirect onto when you detect mobile. You might decide to go fully responsive and just serve all the same content to the device and let it work it out what it wants to show. And I'm not here to debate which one's better, but there is one that's a problem with a CDN model. And that's the idea where the web server is doing user agent sniffing and then deciding to send device-specific content for the same URL. And in this case, you don't want to have one desktop ask for the home page and serve it the desktop homepage content, and then have the mobile ask for the home page and then serve it from the cache and give it the desktop content. You need to break the cache up. But a cache needs to make a decision on whether something's a match based purely on what's in the request headers. And HTTP has a model for this. It's called the vary response header, and it basically says this is a response header, or sorry, this is a request header that you should use and consider it part of the cache key in addition to the URL. Use it as part of the cache key in addition to the URL to decide what works. And this solves the problem. Suddenly, user turns up and says, I'm on IE9, whatever, and go, yep, cool, we've go request that, keep that, and we can give it to other people with the same user agent string. And you'll only ever serve content that matches their user agent. Unfortunately, user agent strings are ridiculously diverse. You've got OS versions, you've got browser versions, you've got processor architecture, you've got plugins, and I think for a while there we had, what flavor of .NET you had installed. You end up with hundreds of variants of user agent, and you end up with corresponding hundreds of buckets for a particular single URL to be cached into. And you just obliterate the chance of someone else coming along with exactly the same user agent string and getting a cache hit before that object expires. And so that's a really tough thing to do. We solve it for a lot of our customers who are going to continue using that model, usually because they're based on a particular product that just works that way, by moving the user agent sniffing into the CDN. And so when the request comes in, we can distill the user agent down into a couple of buckets. We can then use that as part of the cache key, and in the event that it's a miss, we can pass that information about which bucket it fell into up to the origin, and then the origin can serve the corresponding content. We get it down to just, this URL, it's desktop or it's mobile. Or maybe a third bucket for tablet, high DPI, whatever. Who knows what cross-site request forgery is? Awesome, awesome. So just to be clear here, for those who may be not sure, cross-site request forgery is the idea that a third-party site could construct a form that could covertly trick a user into submitting off to another site. And then because the browser is going to supply the cookies for the other site, if that user has been there recently and logged in recently, it's going to appear to that other site that it was a legitimate request. And that could be just a Facebook like, or it could be a Amazon one-click buy operation. And obviously this is a problem. So secure sites want to mitigate this. And a really popular approach that is effective is to use anti-CS RF tokens. And the model is basically that each user session gets a random token which is stored on the server. And when the website generates the page for that user, it's obviously the user has their session cookie, and in the page, in the form, it'll include a hidden field which is a unique key. And when the form is submitted, the site looks for the key, looks up the corresponding session user data, and makes sure the keys match. If it does, cool. If it's not, it rejects the request. And because of the way browsers are built and with CORS rules and things like that, this makes it really hard to circumvent from another site. The problem is that we end up with programming frameworks that just decide, all right, security is too hard for people, so we're just going to mandate that any post request has got to have CSRF. Now, imagine a site where their homepage lists their top 10 products. And for convenience, every product has next to it a little add to cart button, which is a form post which needs to include the CSRF key. And that means that now the homepage needs to have every user have a session ID, and every version of that page needs to have a key for every particular user. You can't cache and share that. And yeah, like that just is going to destroy your ability to use a cache. And what the real problem here is you need to think about what it means for a privileged operation to need to be protected with CSRF, especially with tokens. Now, beginning the checkout process, definitely get CSRF in there. Changing your password, definitely. Adding an item to your wish list, probably. But adding an item to your cart as a user who is not currently registered or logged in any way, that doesn't hurt. And you can still mitigate it without a CSRF token. You can take a slightly sort of middle-of-the-road approach of just using referrer or origin checking. Not going to prevent sort of fiddler and curl-based attacks, but it stops browser-based attacks, which is the most common vector. I think hopefully there's a theme that's developed here, and that is that user-specific content is a problem if you want to get the most out of a caching proxy. You want either a large resource which takes time to render, to have nothing but common data for everybody, and then really small bits that are specific to a user. So take a page which says, "Hi Bob" at the top when you're logged in. That's on every page of the site. And if you're rendering that into the markup for every user, that's really hard to deal with. But if you can just serve a page with a bit of a placeholder there, maybe it just says hi, maybe it says nothing. And then the page does another AJAX call to go, hey, just give me the bit that tells me their name. That's so much more efficient. And in fact, in that case, why even go back to the server? Is it really a big deal if you just store their name in the client in local storage and just go, hey, we think you're Bob. Hi, Bob. You know, that's not a security vulnerability. And a lot of things don't really need to go to the server straight away. Add to cart. Like, until you are ready to actually check out, or maybe this user leaves the site and you want to capture some abandoned cart information, server doesn't care what's in your cart until you're ready to buy it. So just use local client-side storage to track all of that. Hopefully some of this was useful to you. Thanks for listening to me waffle on about it. If you want to ask any questions after the fact, I'm around all afternoon. Anything to do with CDNs, web performance, HTTPS, or just stuff in general. Thank you very much.